Rheology is the study of the flow of matter, primarily in a liquid state, but also as soft solids or solids under conditions in which they respond with plastic flow rather than deforming elastically in response to an applied force. It applies to substances which have a complex microstructure, such as muds, sludges, suspensions, polymers and other glass formers, for example, silicates, as well as many foods and additives, bodily fluids, for example, blood, and other biological materials or other materials which belong to the class of soft matter such as food. Newtonian fluids can be characterized by a single coefficient of viscosity for a specific temperature. Although this viscosity will change with temperature, it does not change with the strain rate. Only a small group of fluids exhibit such constant viscosity. The large class of fluids whose viscosity changes with the strain rate, the relative flow velocity, are called non-Newtonian fluids. Rheology generally accounts for the behavior of non-Newtonian fluids by characterizing the minimum number of functions that are needed to relate stresses with rate of change of strain or strain rates. For example, ketchup can have its viscosity reduced by shaking or other forms of mechanical agitation, where the relative movement of different layers in the material actually causes the reduction in viscosity, but water cannot. Ketchup is a shear-thinning material, like yogurt and emulsion paint, U.S. terminology latex paint or acrylic paint, exhibiting thixotropy, where an increase in relative flow velocity will cause a reduction in viscosity, for example, by stirring. Some other non-Newtonian materials show the opposite behavior, rheopecty, viscosity going up with relative deformation, and are called shear-thickening or dilatant materials. Since Sir Isaac Newton originated the concept of viscosity, the study of liquids with strain rate-dependent viscosity is also often called non-Newtonian fluid mechanics. The term rheology was coined by Eugene C. Bingham, a professor at Lafayette College, in 1920, from a suggestion by a colleague, Marcus Reiner. The term was inspired by the aphorism of Simplicis, often attributed to Heraclitus, Pantare, everything flows. The experimental characterization of a material's rheological behavior is known as rheometry, although the term rheology is frequently used synonymously with rheometry, particularly by experimentalists. Theoretical aspects of rheology are the relation of the flow/deformation behavior of material and its internal structure, for example, the orientation and elongation of polymer molecules, and the flow/deformation behavior of materials that cannot be described by classical fluid mechanics or elasticity.